Good morning, Algebra 2. So we're going to continue with our probability section here. So we're going to check out what we call compound events, when we have more than one event happening, and how we can calculate the probability of certain situations occurring. So we're going to check out two different deals here. One of them is going to be independent events, and that's when the outcome of one event does not affect the outcome of the other event. Okay, the way that's going to be written is the probability of A and B. And all we have to do is take the probability of A and multiply it by the probability of B. And that'll give us the probability of both those events occurring. Okay? We also have dependent events. So that's when the outcome of one event does affect the outcome of the other event. In this situation, you're going to take the probability of A and multiply it by the probability of B after A has occurred. Okay? So in this situation, these are situations where whatever happens in that first situation, outcome A, it's going to change what's going to be happening with outcome B a little bit. So let's first focus in on this guy right here, the independent events. These guys are a tad easier. So let's check out number 11. I'm going to zoom in a little bit here. So we have a die is rolled 3 times. What is the probability of getting ones on each roll? So there's 6 numbers on a die, right? And we have a 1 in 6 chance of getting a 1, right? So if I'm trying to get a 1 every single time, okay, that's 3 different outcomes that I want, and there's a 1 in 6 chance each time. I'm just going to multiply 1 over 6 times 1 over 6 times 1 over 6. Remember, when you're multiplying fractions, you just multiply across. This can be 1 over 6 times 6 times 6 is 216. Okay, so for number 12, it says a coin is tossed, then a day of the week is selected. What is the probability of getting tails, then a day starting with the letter T? So with the coin, we have 1 in 2 chance, right? It's either going to be head or tails. Okay, and then for that day, the week starting with the letter T, we got Tuesday and Thursday, and that's it, right? So that's 2 out of 7. So those are the probability of each of our outcomes occurring. And so we got to multiply them together, and we get 2 out of 14, which reduces to 1 over 7. So there's a 1 in 7 chance of that happening. Okay. So here we have a bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. A crayon is selected, replaced, and then another is selected. Find each probability. So the key here is noticing that they said they're selected and then replaced, and then another is selected. So first off, we have to figure out what the total is going to be. And it looks like we have 8 plus 14, and that's 22, plus 6 is 28, plus 4 is 32 total. So first one we're looking at is purple, then yellow. So for purple, there's a 14 out of 32 chance we grab a purple, right? And then remember, after we grab one, we're replacing it. It's going back in there. So we still have 32 total. And the next one is yellow we're looking for. So 6 out of yellow for yellow there. Okay, and what I'm going to do, just to make my life a little bit easier, instead of multiplying straight up first, I'm going to reduce both of them. So this guy looks like 2 goes into the top and bottom, so that's 7 over 16. Times 6 over 32, 2 goes into those guys, that's 3 over 16. So we get 21 over 256. So it made it a little bit easier to reduce those guys. All right, so the rest of these guys I think are pretty easy. So go ahead and pause and try out the last 3 here. And when you're ready to check, unpause and I'll show you what's up here. So here's green then red. So green is 4 out of 32. Red is going to be 8 out of 32. I'm going to reduce these guys. This is 4 over 32 is 1 over 8. 8 over 32 is 1 over 4. So that's going to be 1 over 32. There's a chance of that occurring. 2 purples, I got 14 out of 32. Remember, we're replacing it, so the next one's the same exact deal. And I'm going to reduce both of them. So that's 7 over 16 times 7 over 16. That's 49 over 256. And then 2 yellow is 6 over 32 times 6 over 32. I'm going to reduce both of them and get 3 over 16 times 3 over 16, which is 9 out of 256. All right. So now let's move on to dependent events. So with dependent events, okay, we're going to go ahead and use the same example from above, but assume that once a crayon is selected, it is not replaced. So that's the key here. It's not replaced. So what's that going to do? It's going to make our total go down, right? After we select a crayon, right, we're going to be from 32 down to 31. Okay, so we got to make an adjustment on that second probability. So for the probability of yellow, then red, okay, we're going to go ahead and we know that there's 6 out of 32 chance of getting a yellow times the probability of getting red. Remember that yellow that we chose is not going to be replaced, is going to be out of 31, and there's going to be 8 reds left. Right, so then we got to go ahead. I'm going to reduce this guy to 3 over 16. And we get something like 24 over 32, or sorry, 16 times 31. Actually, you know what I just noticed? Okay, we can actually reduce this guy down a little bit. The 8 over 16, make our life a lot easier, is 1 over 2, right? So that's just going to be 3 over 2 times 31 is 62. Right? So notice the big thing here is that our total went down because we weren't replacing. Right? So now let's check out, let's have you guys try 18. So pause and give that guy a go. Right? Now I'm going to continue on, so unpause when you're ready. Purple, we have 14 out of 32. And then green is going to be 4 out of 31. Right. So in this scenario, I'm going to reduce a little bit. That's going to be 7 over 16 when I reduce that guy. The 4 over 16 is really just 1 over 4, right? So I got 7 over 4 times 31 is 124. Okay. In some scenarios, we're going to have to adjust both the top and bottom. For example, if we have 2 reds we want to choose, and we know that we're not replacing, okay, we're going to have 8 out of 32 chance on the first guy, but now there's only 7 reds left, because if our outcome occurs, right, one of the reds is going to be gone, so we're going to have 7 out of 31 for our second guy. Right, so this guy reduces 8 over 32, reduces to 1 over 4. And we get 7 out of 124 chance of that occurring. So go ahead and try number 20. It's similar. Right? So pause the video and then I'm going to show you here. So we have a 4 out of 32 chance of picking a green. And then to pick the second green, where there's only 3 greens left and 31 total. Right? So let's reduce a little bit. That's going to be 1 over 8 times 3 over 31. And that's a 3, and then 8 times 31 is 248. Okay, so go ahead and try, let's try 21 and 22 on your own, right? And then I'll explain them. So pause it, and then go ahead and try these guys out. So remember there's 52 cards in a deck, right? We're not replacing these guys. Right, and we're drawing 2 of them. What's the probability of choosing a heart then a spade? So the first, there's 13 hearts out of 52, right? And then we're not replacing, so then the chance of drawing a spade is going to be 13. There's 13 spades, but we're only going to have 51 cards left if we already chose one, right? So in this scenario, 13 over 52 reduces to 1 over 4. So we're just going to have 1 over 4 times 13 over 51. And that's 13 over 204. And for 22, Jack had 4 Snicker bars and 8 Mars bars. He randomly chose a piece of candy, ate it, then chose another. What is the probability that both candy bars were Snickers? So it looks like he has 12 total. So there's a 4 in 12 chance of him getting a Snickers on his first one. Okay? And then if you got a Snickers, there's only going to be 3 of those left out of 11 total, right? So that should be our combo. 4 over 12 is 1 over 3. The 3s are going to cancel, actually. It looks like we get 1 in 11 chance. Okay, so that's compound events. The way I want you to practice that is go to the homework 2 and do 13 through 25 odds. All right. Hope you guys have a great day.